Today's tutorial is about demodulation. Since in my previous tutorial, we have been able to talk about modulation and we were able to generate the general EM wave modulation by using the various techniques, which is the square law method and the switching characteristics of diode, or the switching method. From there, we were able to expand it by using trigonometric identities to simplify, and we came up with the various components of the individual EM wave. And today we are going to talk about demodulation. Demodulation is an essential part of any communication systems. So I can say that without demodulation, modulation is essentially nothing. To kick off, demodulation is the process of extracting the original information signal from a modulated wave signal. As we mentioned earlier on, modulation is the process of superimposing the information signal onto a carrier wave, which mostly allow us to transmit information over a long distance or maybe through a noisy area. As such, we can say that demodulation is the reverse process of modulation, since it helps us to recover the original information signal from the modulated carrier wave signal. To move on, there are many different types of modulation and demodulation techniques, as we have talked about modulation technique already, which was the square law modulation and the switching method. As such, they all work on the same basic principle, in the sense that the modulated carrier wave is being passed through the demodulator in the case of demodulation, which can be a circuit or maybe any algorithm that has been designed to extract the original information signal that we want, or that is our interest. So, not wasting much time, it will not be possible to recover the original information signal from a modulated wave if we don't do demodulation. And therefore, we can say that demodulation is actually an important concept as far as communication systems is concerned. Looking at demodulation, this demodulation over here is used in a variety of applications, of which some include the radio broadcasting. The next one also is about television broadcasting, satellite communication, and also mobile phone communication. So, since now we know some of the applications of demodulation, let's quickly look into the various demodulators. So, as you can see here, we have the two main types of demodulators for EM wave. The first one that we would like to talk about is the square law demodulator. That is the square law demodulator. So, looking at the square law demodulator, it's more or less the same as the square law modulator, or the modulation that we did using the square law method. Just that for this square law demodulator, after passing it through the nonlinear device, you pass the output of the nonlinear device through a low pass filter. And we talk about the reason why we pass it through a low pass filter. So let's look at this in this way. This is the square law method. In modulation, we were saying that we needed only two signals, which is the message signal, M of t, and then the carrier signal, C of t. But due to the fact that this is not modulation, we are not going to use these ones. And as I explained earlier on, demodulation is the process of extracting the original information. This means that the information that we want to demodulate has already been modulated, and therefore we came up with a particular equation when we were doing modulation, like AC into bracket 1 plus k m of t multiplied by cos omega ct. So if you remember, this is one of the main equations that we derive using the different method of modulation, which is the square law and the switching method. So when we are doing modulation, this is equal to our s of t. Demodulation, this is equal to our s of t. So in that way, we are going to put this one as our input to the nonlinear device. So let me do some SketchUp here. During the modulation, this is the modulation. We needed two signals, which is the message signal and then the carrier signal. This m of t, and this is c of t. And this signal is going to be our input. And this input is going to be fed through the nonlinear device. And then from there, we pass it through a bandpass filter. This is the modulation. This is the modulation. So if you look at this one, you can see that the input here, which is V1, is going to be V1 equal to m of t plus c of t, which is going to be the input to that of the nonlinear device. And then the output to the linear device, V out, is going to be passed through the bandpass filter to remove the extra noise to get s of t. So if you have not watched my previous tutorial, you can go back and then do some sort of revision on it about modulation. So this is what we discussed about modulation. When we come to demodulation, that is the other way around. Even though we are using the same demodulator, which is a square law demodulator, and we are using the same nonlinear device, the input is going to be the modulated wave signal, which is s of t. This is the nonlinear device. And then the output, instead of passing it through the low band pass filter, we are passing it through a low pass filter. And from there, we are getting our message signal, which is m of t. Let's look at the reason why we pass the output here of the nonlinear device into a low pass filter. As I explained earlier on, we are extracting the original message from the modulated wave. And in one of my tutorials, I was saying that the carrier signal has a higher frequency and the message signal has a lower frequency. And we use this carrier signal, which is which is having a higher frequency, to modulate the message signal, which is having a lower frequency. So in this way, we have a mix of both lower and higher frequencies. So if we want to extract back our original information, it means that we need the information with the lower frequency, which is what? The message signal. And therefore, this low band pass filter will allow us to get all the low pass or the message signal with the lower frequencies. That is, it allows lower frequencies to pass whilst blocking any other frequencies. So in this way, we'll be able to extract our message signal from the modulated wave signal. So this is about demodulation. Now let's look at the square law. This is basically about the demodulation, and we talked about the square law and then the envelope detector. And I wanted to talk about the square law over here. And it was important for me to establish the difference between the modulation and then the demodulation over here using these two diagrams. Now, since we now know the difference between the demodulation and demodulation in terms of the block diagram that we did over here, let's move on and talk about the square law.